In this problem, we're given a polynomial f of x, and here it is over here. And nicely, it's already in factored form. That's going to save us a lot of work. We need to state the degree of the polynomial and use that to determine the end behavior of the graph. We need to state the zeros of the polynomial and find the multiplicity of each zero, and then we need to sketch the graph. Well, I prefer to start with part B, finding the zeros and the multiplicity. That will help us find part A, and then both of those will help us sketch the graph. So the first thing I want to do is find the zeros of the polynomial. That means set f of x equal to 0, so my whole polynomial has to equal 0. So I'm going to have negative 2 times x plus 5 squared times x minus 3 squared times x plus 1 has to equal 0 to find the zeros of the polynomial. Since it's already factored, all we have to do is set each factor equal to 0. So the first one, negative 2 equals 0. Well, does that make sense? No, negative 2 always equals negative 2. So if you just have a common factor of a number, it won't give you a 0. So now let's take x plus 5 squared and set that equal to 0. Well, that is equal to 0 when x plus 5 equals 0. And remember, how do you solve this? We're going to subtract 5 from both sides, so you're going to get x equals negative 5. Now let's look at our next factor, x minus 3 all squared equals 0. That means x minus 3 has to equal 0. And if I add 3 to both sides, what am I going to get? X equals 3. My last factor is x plus 1 equals 0. Just to remind you, what exponent is on this parentheses? There's a 1 up there. So I get x plus 1 equals 0, or if I subtract 1 from both sides, I'm going to get x equals negative 1. So now what we're going to do is fill in this table. I'm going to put each of my factors involving x. So I have x plus 5 squared is my first factor. The 0 we found to go with it was x equals negative 5. And what's the multiplicity? The multiplicity is the exponent on the factor. So this one has a multiplicity of 2. And remember, when the multiplicity of a 0 is even, as 2 is even, it's going to touch the graph and turn around. Sometimes it says touch and turn around, sometimes it says bounce and turn around. It means the same thing. The next factor was x minus 3 all squared, and the 0 we found was x equals 3. Here, what's the multiplicity? 2. And again, multiplicity 2, it's going to touch and turn around. That means it will not cross the x-axis. The last factor was x plus 1. And remember, that was to the first power. The 0 was x equals negative 1. What's the multiplicity? What's the power on the exponent? 1. And now, when the multiplicity is odd, it's going to cross the x-axis. So now we've found our zeros. We've found the multiplicity. And now the easiest way to find the degree is add the multiplicities up. What is 2 plus 2 plus 1? Well, 2 plus 2 is 4, plus 1 is 5. So the degree of this polynomial is going to equal 5. So we know we have a degree equals 5. And now we have to figure out the end behavior. Now remember, the end behavior is determined by the degree and the leading coefficient. Well, what is the leading coefficient for this polynomial? Here's the leading coefficient. It's negative 2. And when the degree is odd, it tells you that the opposite ends are going to point in opposite directions. And since the leading coefficient is negative, this is the one that starts up to the left and down to the right. And so if we're asked to describe this, we can say that it rises to the left and it falls to the right. In order to graph this polynomial, I've summarized the information from my last slide. Here's the end behavior. Here are all the zeros and the behavior. And remember, I think on the other slide, I said it touches and turns around. That means the same as bounce and turn around. So what I have to do is plot each of my zeros on the x-axis, and I need a consistent scale on the x-axis, so I'm just going to have 1 square is 1 unit. So I have -2, -4, and -6 in that direction, 2, 4 in the positive direction. I don't need to state the scale on the y-axis since I'm just going to sketch the graph. So the first thing I have to do is plot my zeros. So the first one was x equals -5, which is right there. The next one is x equals -1, which is right there. And the last one was x equals 3. So there are my zeros. Now I'm going to add in my end behavior. I know my graph rises to the left and falls to the right. So my graph has to come down from here. Now what does it do at -5? It's going to come down, it's not going to cross, it's going to bounce and turn around. So let's sketch that part in if we can. So it's going to come down, it's going to bounce, and it's going to turn around. And now we have to look at where is the next zero, right here at -1. And what does it do at -1? It crosses the x-axis. So it's going to have to come back up and then go down and cross. So let's graph that part in. So it's going to come down and cross at -1. And then finally, at our last zero of x equals 3, it's going to bounce and turn around. So it has to go back up. It's going to bounce and come back down, and that's good because it matches my end behavior. So let's just sketch in the last part. There is a picture of my graph. We're just sketching it. We just want to know its basic shape. Where does it cross the x-axis? Where does it touch and turn around? And so your graph will look something like that. We don't know how high up it goes here or down here. What we're interested in is its basic shape.